Welcome back to another video. Dear students, in this video you will learn one of the concepts of chemical equilibrium, and this is law of mass action. This is one of the basic concepts of this. So before starting this, I just want you to check out previous two videos of chemical equilibrium. I will give you the links of those videos in the description, so you may check them out if you want to learn. So let's start today's video, and this is law of mass action. Well, this law of mass action was put forward by two scientists, the Goldberg and Weige, and they gave this law in the year 1869. What did they do? They actually examined many reversible reactions. If you want to recall the concept of reversible reactions, then reversible reactions are those reactions which are continuous, they never stop, and you can see the forward reaction is happening, and simultaneously the reverse reaction is also happening. So these are the types of reactions that are continuous. So Goldberg and Weige, they actually examined the reversible reactions, and then they put forward this law in the year 1869. Basically, this law tells you about the rate of reaction by examining the rate of forward reaction and the rate of backward reaction. So what does this law say? We will see the statement. The rate at which a substance reacts is directly proportional to its active mass. What is active mass? I will tell you. And the rate of a reaction is directly proportional to the product of the active masses of the reacting substances. So how does it proceed? We'll see with the help of an example. But before this, I just want you to recall few basic things that you must be knowing. One of the things is new for you, or it might not be new for you, but I just want to discuss it here. Active mass. Active mass is basically the concentration of a reacting substance. So what is active mass? It is the concentration of a reacting substance. How do you express it? Like, what is its unit? It is mole per cubic decimeter. And how do you express it? You express it inside the square brackets. You express it with the help of square brackets, and whatever reactant is there, you just enclose it in here. So the whole thing will express the active mass of the reacting substance. Now you know about rate of reaction. It is the speed at which a chemical reaction is happening. Mole is equal to the Avogadro's number, the value of Avogadro's number, that is 6.023 into 10 raised to power 23, and it is used to measure the products obtained from the chemical reaction, while molarity is the number of moles of a solute per liter of a solution. So active mass is also known as the molar concentration. Like in general term, it is known as the molar concentration. Now move with the example. So here there is an example of a reversible reaction. You can see here A and B, they are reactant, and when they are reacting, they are proceeding to forward reaction, and they are giving the products C and D. While C and D, they get optimum conditions, then they reproduce, like they give you back A and B. One thing is new, Kf and Kr. These are basically the rate constants. Kf stands for the rate constant of the forward reaction, while Kr is representing the rate constant of the reverse reaction. Here, like under square brackets, inside square brackets, I just enclosed A, B, C and D. So they are the molar concentrations of the reactants A, B, C and D. According to law of mass action, the rate of forward reaction is directly proportional to the molar concentration of A multiplied by molar concentration of B. So it is the product of molar concentrations of A and B, and both of them are reactants. So if you want to replace this proportionality sign, then you replace it with the rate constant. So rate of forward reaction is equal to rate constant of the forward reaction with the product of molar concentration of A and B. Similarly, the rate of reverse reaction is directly proportional to molar concentrations of C and D. And whenever you replace this sign with any constant, you have to put a constant. So this is rate constant of reverse reaction to the product of molar concentration of C into D. So this is the product of molar concentration of C and D, and this is the rate constant of the reverse reaction. You know that at equilibrium state, the rate of forward reaction is always equal to the rate of reverse reaction. Here you just found out the rate of forward reaction and the rate of backward reaction. Now when we put it here, then it is just like this: Kf multiplied by molar concentration of A and molar concentration of B, and same goes with the rate of reverse reaction. So if you want to make it simple, then Kf will stay here, Kr will be moved here. Since it is multiplying here, so it will come here on the left side and it will divide. So Kf upon Kr. Here the CD are same, the molar concentration of C and molar concentration of D are same. Now these A and B will move here, so it will take the form like this. Okay, so if you want to replace them, then instead of them you can write one thing here, Kc. Instead of writing Kf upon Kr, like Kc equals to Kf upon Kr, so you can simplify it by writing it here. Kc equals to molar concentration of C multiplied by molar concentration of D divided by molar concentration of A to molar concentration of B. Since Kc here is representing the equilibrium constant, so at this position, this proves the law of mass action. The rate at which a substance reacts is directly proportional to its active mass, and the rate of reaction is directly proportional to the product of the active masses of the reacting substances. So I hope that you understood it. If you have any query, then you may ask it in the comment. So I will see you in the next video. Till then, take care.